So now we come to the notorious two-triangle law of sines example. And like most things in math, when something seems complicated, let's just start with something we understand and have done a lot of, and that is finding the contained side across from the angle that's given, and then comparing that to the altitude. Now, if the contained side that is across from the given angle is greater than the altitude, then you have a triangle, which makes sense. Otherwise, your altitude's too tall. This thing is just hanging around it. It can't hit the ground. And so to have two triangles, that contained side would have to then be less than the hypotenuse of this interior triangle that you use to find the altitude, meaning this one. Some people will say, is A less than the adjacent side, because it is side angle. There's only one more side, so they just call it the adjacent. But that's what we're looking for. We're looking for a triangle that exists such that this side is smaller than that side. Now, visually, the reason this happens is, if you have a triangle that exists, then the side will hit the ground here, forming your just classic oblique triangle. But if it's just right, it'll go through here, pick it back up, it'll fit right in there, making this little sliver triangle. So let's take a look at actual numbers here. Let's get some concrete information. So we have a side A that's across from the given, meaning making it the contained, and then another side. Always draw this as side angle. That's the whole point. That's the ambiguous case. And so we have this classic example that we've seen several times. And the altitude in this interior triangle, the altitude is opposite over hypotenuse or sine. So sine of 25 would be altitude over 9. You multiply 9 on both sides, you get the altitude is 9 sine 25, which comes out to 3.804. And that number is smaller than 5, making a triangle. Otherwise, if the altitude were too large and that were 5, then it would look like that. It wouldn't touch the ground. So the first piece of analysis is always, do you have a triangle? And the answer in this case is yes, I have a triangle. Then you move on to how many there are. So how many triangles are there? Well, if you look at the contained side, it is smaller than the hypotenuse of that interior triangle, otherwise known as the adjacent. 5 is smaller than 9, making a triangle right there, as well as the one you see. And so that's how we get two triangles. Now, again, in the idea of just, not freaking out about math, the first example is just the one you're seeing here, right? I have a key ratio of 5 divided by sine of 25. I'm going to set that equal to this side, which is this angle, which is across from side B. So I'll call that B. I'm just going to do the same thing I have been doing, right? So take this triangle, set up my key ratio, 5 divided by sine of 25 is equal to 9 divided by sine of B. I'm going to cross multiply, and I'll get 5 sine B of 9 sine 25. I'm going to solve for sine B by dividing by 5. Keep in mind, since I'm finding an angle, I have to inverse sine, just like you did, back when you were doing regular right angle, SOHCAHTOA, sine, cosine, tangent trig. If you need to find an angle, you have to use inverse sine. So you inverse sine this ratio, B is inverse sine of that ratio, and you get this first angle. Now that angle is the key to the second triangle as well, which we'll talk about in just a couple of moments. So what do I do once I get B? Once I have B, to find C, I'm going to use angle sum. So to find C, I use angle sum. I take 180 degrees, subtract the given 25, subtract the just found 49.57527, giving me this 105.7473, which is clearly obtuse, which makes sense. Make sure what you're doing, that's an obtuse angle, so that's an obtuse value. Make sure what you're doing makes sense as you're going along, so you don't get overwhelmed. I'm going to go back to this key ratio and use it again to find side C. So 5 over sine of 25 is equal to side C divided by sine of the angle I just found that corresponds to side C. I cross multiply, giving me C sine 25 equals 5 sine 105.473. And I divide by sine of 25. I do not need to use inverse because I'm finding a side. Remember, sides use sine and cosine and tangent. Angles use inverse sine, inverse cosine, inverse tangent. And so I typed that into the calculator and I get 11.402. Could, of course, done all that on Desmos as well, or Casio, or what have you. So now I just write out what the first triangle is. I was given 25 degrees. That was directly across from the side A, which was 5. I was also given 9. I found 49.527 using the law of sines. I then found 105.473 using the Angle Sum Theorem. And then I used the Angle Sum Theorem right here to find side C with the law of sines. Then I got 11.402. So triangle 1, same boring law of sines stuff that you've always been doing. So now how do I find the second triangle? So what happens is, in the first triangle, I could have drawn, right, here's my first triangle, I could have drawn that 5 right over here instead, right? So that 5 could have been there. I chose to draw this larger triangle, but doesn't this triangle right here meet all of the characteristics that I was given, right? This has a 25 degrees, it has a side that's 5, it has a B that's 9. That little triangle meets all the characteristics, and it's possible based on this analysis that we did here. So what do? Well, I don't just use the same key ratio to find B. I will use it later, but I don't use it to find angle B, because if I use it to find angle B, I'm going to get the same result. What I do is I have to understand that this triangle here is key to understanding how to find the new little triangle that I've drawn now over here. So how do I do it? Well, what I do is I take this angle and I realize that I actually have an isosceles triangle. I have this is equal to this, and we learn in geometry that that means, okay, that this angle is also here. So all of this is outside of this little triangle, but is key to finding this angle right here. Like, how do I find that angle? I now have a linear pair, and that linear pair has 49.527 from the previous problem that came from it being isosceles. So how do I find this angle? I don't use trig, I actually use geometry. And remember, geometry is the study of shapes. And so when you look at this, all of this up here, other than this piece to find the altitude, it's really the study of what kind of shape we have. So to find this new B here, to find new B, what I do is I actually use the linear pair, that it's actually 180 minus the one I found earlier. So new B is found by taking 180 degrees minus old B from geometry and linear pairs. I just take 180 and I subtract 49.527 from over here, and I get that new B is 130.473 degrees. Well, that's important to understand. That's the critical piece. Notice that it is obtuse, and that's obtuse. So it does all kind of fit into, the pieces fit in where they should. At that point, once I understand that this is not trig, that it's geometry, every piece of it from this point is identical to over here using new numbers. What did I do after I found this 49.527? I used the Angle Sum Theorem. I'm going to do that again, but now I'm going to do it with this number. So I take 180, I subtract the given 25, I subtract 130.473, and that gives me that new C, right? We'll call this new C. New C is 24.527 degrees. I then look here what I did here. I used a key ratio. I found little c. I'm going to do the exact same thing. Key ratio, find little c, but I'm using my new c to do it with. So then I cross multiply. I get 5 sine 24.527 degrees. I cross multiply. That gives me c sine 25. I then divide by 25 on sine of 25 on both sides. I type this into the calculator and I get a new little side c of 4.911. Then I organize the information, and it's really interesting when you look at them side by side. A is the same as A. Side A, same as side A. B, same as side B. This is where the difference happens. This angle right here is the supplement of this angle. And if that's all you really want to worry about, you don't even have to draw this picture. I mean, you have to understand where it comes from, but if you just want to understand that the second triangle is always the supplement of the adjacent side, so you're given 25 and 5, so to find the second triangle, the other side, whatever it is, that angle, just subtract 180 and you can do the other problem. You don't have to draw that picture unless it helps you. Then from there, use the angle sum to find C, and then from there, use the law of sines to find new little c. Try not to overcomplicate it. and just look at the connection between this and this, maybe the picture confuses you. But if you can subtract from 180 degrees, you can do this. 180 minus this is that, and then from there, just redo the same problem, starting with the angle sum, and then using the key ratio, and you'll get the second triangle.